Thank you. I was looking through my slides yesterday. Oh, where's my scroll bar? I can't see it in this monitor. Hiding, there it is. So I was looking through my slides, and I've been speaking all over the world. And I was looking at when I was last here, and it was in 2008, apparently. I can't see that far. Oh, here it is. I was looking for St. Augustine, but for some reason I just called it some small town in Germany. Yeah, August 24th. Some small town in Germany. So that was my last talk, Simple as Hard, many years ago when I started talking about stuff like that. But we're not going to talk about that. We're talking about PHP 7 this time. My slides are online, talks.php.net. You can go look at the last 20 years of my talks on there. The older ones are kind of badly formatted now, but grab them from Git if you want. So, yeah, really, 20 years of PHP. It was fun listening to Mad Dog earlier, talking about how Linux got started and things. And I remember sitting with floppy disks in late 93, like I think it was 25 of them, and then you get to the 23rd and it doesn't read. There's a read error on the disk and you have to start all over. Terrible. But I eventually got through it, and that's when I started PHP basically. Once I got I was running SCO Linux or SCO Unix beforehand, but it wasn't until Linux hit with all the tool chains and all the gear to actually start building things, have debuggers, compilers. All that was too hard before Linux. Linux really drove this whole industry for us. So by June 8th, I had played with enough floppies and gotten the system up and running to announce it. And the announcement is here. It was posted to Usenet, which was this thing that previous generation used instead of Facebook and whatever else the kids use these days. But we actually discussed things on Usenet newsgroups. And I posted this to Comp Info Systems, authoring CGI. And as you can see, I didn't really describe PHP as you know it today. I described it as a bunch of things you could solve using this tool. And it's a nice snapshot of what were the issues people had on the web in 1995. And it's hidden in here. I mean, PHP is kind of here, easily create and display forms, right? And the ability to use information in the following documents. So you put up a form, you post the information to the next page, and then you can use that information somehow. I don't go into the fact that there are variables and you can do things, you can stuff it into a database. It's kind of implied, but people weren't used to that back then. People were used to static web pages, right? There was no such thing as the dynamic web in 1994. The web was like a newspaper. You'd go to the website each morning and see, hey, is there any new content here? And once you've read it, that's it. There's nothing else. I mean, it's not like you could log in, you couldn't do anything. It was just basically a digital newspaper at that point. So you didn't need anything, you didn't need a scripting language for the web back then. It was starting to come, but the vast majority of people didn't really connect with the idea of a dynamic web. So people were mostly interested in just logging who came to their pages, right? So that's why there's a lot of stuff about logging in here. So tracking who accessed the page and putting all that information in a database so you can create reports, things like that. But what I was actually trying to do in a very sneaky way, which completely failed, was to introduce this C API for the web. So all these various logging tools and all these things that I built were built on top of this very simple, or I thought it was simple, C API that then could be used to create or extend the templating system that I was providing. So the templating system basically just had a set of tags that I had provided as default implementations. They were essentially just examples. So here are a bunch of tags. They happen to talk about logging and put stuff into a database related to logs, but those tags could easily be changed or duplicated and changed slightly to do other things. I figured people would be writing business logic in a strongly typed language, compiled language, debuggers and all these things. I really didn't foresee that people would write large, complex applications in PHP itself. To me, it was just a display part. And all the business logic would be written like this, basically. Hold on. So here, if you wanted to implement a cosine tag, if for some reason you wanted to put cosines into your template, this is all you had to do. It was stack-based, so you'd pop the argument off the stack, check it, make sure there was something there, then perform the cosine operation, and you push the result back onto the stack, and you tell it that it's a double. D number stood for double. And that's all you had to do. Then you would have this cosine function available in the templating system that you could then use. So you didn't have to worry about how do we compile it into Apache, how do we, well, there was no Apache back then, but how do we interface with the web server, how do we spit stuff out, how do we parse a post document, how do we get the stuff in? You just had to write just the core of your business logic in C, and everything else was handed to you on a platter. But my platter wasn't big enough. People just did not want to write C at all. No matter how simple I made the C API, people refused because C was too hard. And the web was moving so fast that it was non-programmers that were tasked with solving the web problem. It tended to be the tech guys, the tech writers in companies that ended up becoming the web team. And the tech writers, I mean, they became the web team because they were asked, hey, this web thing that's new and exciting, let's get something up there. Let's put our documentation up. Release notes, upgrade guides, anything like that. And the tech writers who wrote that stuff said, sure, whatever. Microsoft Word, save as HTML, we're done, right? But when they then came back and said, let's put our inventory up, let's put our support database up, our CRM system, let's make that available. All these things that are way more complex. And they told the web team, go do that. And the web team are sitting there with Microsoft Word, save as, going, there's no save as, big dynamic website, right? And those were the people that ended up using PHP. Much to my annoyance for the first couple of years, I was fighting with the user base essentially, going, what the hell? I mean, I would show them, like, this is so easy. Here's an example. And they would say, well, I see you have, well, it wasn't cosine, but I see you have cosine, why don't you have sine? I'm like, come on, it's like a search and replace. It takes you 2 seconds and I do it for them. And they say, thank you. Now, how about, and I just kept going and going and going like that. I felt like I was the remote programmer for about 100 different companies at the time. And I got a bit burned out. And I essentially stopped. I said, this sucks. Nobody's buying into my idea. Everyone's just expecting me to solve their problems for them. And so I was, for about 3 weeks, I was at the point where I was just ready to toss it. Like, this sucks. There's too many people emailing me, complaining. They're not using my tool the way I want them to. Everyone should just suck eggs and go away. But I didn't. Instead, the smartest of the folks that had been bugging me and complaining, I just said, okay, screw it. Yes, I know my Oracle extension sucks, because I didn't actually have Oracle. I just got the header files from Oracle and compiled it against just the .h file and relied on the user base to tell me if it worked or not. And a guy named Stig in Norway, Stig Bakken, was complaining because he used Oracle, and because I had never used Oracle, I didn't even have Oracle, it didn't work quite right. And he sent me all these bug reports. I said, fine, Steve, it's yours. I don't know anything about Oracle. Take it. It's all yours. And I did that for most of PHP. I just sort of handed off all of PHP to other people to the point where I had nothing left. And this was late 96 or so. Zev and Andy came and said, hey, we looked at your core parser. We've just finished taking a course in Israel, in Tel Aviv, on exactly this, on building compilers. It doesn't look like you've ever taken a course on this stuff. Like, that's very true. Like Mad Dog said earlier today, right? It wasn't computer science folks that were building things in the early days. It was people who were solving problems, right? And I'd honestly never taken a computer science course in my life. We had one. I have an electrical engineering degree, and we had an engineering computer science course, but it was completely crap. There was, I mean, it was there, but it was terrible. It was really, really bad. It was dumbed down for the engineers to the point where it was useless. So, anyway, that's sort of the story, the early days of PHP. I did eventually grab a few things back after giving everything away, to the point where I was comfortable with the workload. But if I hadn't done that, if I hadn't given up control and sort of let it just take its own path and basically let users dictate what PHP should become, then it would have died right then and there. I stopped being stubborn. I stopped rewriting everybody's patches that they sent me, because that was demotivating for the contributors. And I just let everything in. And yeah, some of it has come back to bite me and bite us later on. Some of the early contributions weren't necessarily the best, but it kept the project alive. All right, so we're at PHP 7. There are some massive improvements in PHP 7. The biggest one is 100% plus performance gains on actual real-world applications, which is pretty much miraculous. I mean, it is really, really hard to take something that has been around for as long as PHP and make it more than twice as fast on real-world loads. You can game benchmarks all you want, micro benchmarks, all kinds of things like that easily. You can double, triple, 10x micro benchmarks, no problem, by focusing on them. But taking millions and millions of lines of code of PHP out there in the wild and making all of it twice as fast is quite an achievement, actually. And the guys that worked on that did a really, really good job. Plus doing it in less memory at the same time. We've also added what we call persistent secondary file-based cache for opcache, which means it's an on-disk version of the opcodes that we store in shared memory during opcode caching. The biggest gain here are for high-traffic sites. When they have to restart their servers, you take a bit of a hit because you have to recompile and repopulate the shared memory cache, right? If you have a copy of those compiled opcodes operates on disk, then you can repopulate from disk quite a bit faster than having to recompile. It's obviously not as fast as having it in shared memory, because in shared memory, we actually don't need to copy too much down into local memory. We can point the executor directly at shared memory and just execute out of shared memory. We cannot execute right off disk like that. It doesn't work that way. But, so in a couple of simple tests, if it's 1x time to read an uncompiled index.php, this was, I think it was the WordPress front page I tested this on, then it's 10x faster to get it from shared memory, and it's 4x faster to get it from disk, right? So you get a 4x increase on the restart. And yes, it's only for half a second as you're restarting, but for really busy sites that take thousands and thousands of requests a second, that half a second is thousands of requests, right? And it makes a difference there. Plus, there's sort of a secondary benefit. And the secondary benefit is that from the CLI, because of the way CLI works, it starts up and then tears everything down. You can turn on opcache today on CLI, but it doesn't help you, because that shared memory cache is destroyed as soon as that CLI script ends. It's gone. So the next time you run the same command from the CLI, there's no caching. If you turn on the file-based cache, all your CLI programs end up being about 4 times quicker. Not necessarily, depends what they do. 2 to 4 times quicker, I would say, just based on the caching. Never mind the actual increase in speed of PHP 7 itself. So I tested this with Composer. Composer is a big CLI-based script, right? It's a FAR-based thing. And turning on opcache CLI, the first time when I have to populate the disk cache, it took 0.04 seconds, right? So 40 milliseconds. Now the second time I ran it, 19 milliseconds, so a bit more than twice as fast the second time I ran it. And without disk-based caching, and turning off opcache altogether, because opcache doesn't actually help you, right? It's 33. So you take a slight hit on the first time you run it, but then from then on, it's going to be 33 versus 19 milliseconds. And this wasn't to run the complicated Composer thing. This was just Composer help or whatever, the status screen thing. So for more complex operations, it might help more. And the actual files on disk, I had set my, you saw in my config here, I set my file cache directory to var temp. And in var temp, it actually, you can see the whole structure of opcache inside var temp, right? Inside the far file. So inside the far file, opcache is caching individually all the different pieces of it. I bet most of you haven't actually seen how complex Composer is inside, but it has all this stuff inside it. Because it comes as sort of a nice standalone program right now. It's just Composer. It's a simple little one program script, right? One file script. It's not a one file script. There's a ton of crap inside. A lot of it may not actually need, actually. But. All right. Abstract syntax tree. Personally, this is my favorite feature in PHP 7. I've been playing with it quite a bit. And what this means is that internally, we're now generating an AST, and we use that AST as an intermediate stage for building the op arrays that we then cache in shared memory. But this means that you can go in there and you can ask PHP, hey, give me this AST so I can have a look at it, so I can play with it, I can change it, maybe insert other nodes into the tree. For me, I'm excited about it because of static analysis. And I wrote a little test implementation just to see if I could do it. I have no idea how to write a static analyzer, zero. But I also had no idea how to write a scripting language, right? I mean, you have to start somewhere. So, yes, I have no idea how to write a static analyzer. It's completely crap, but it works pretty damn well for a completely crap static analyzer. And I've taken a lot of flack over it already. People looking at my code going, oh man, what are you doing? Like, well, it kind of works, so please write a better one. I would really, really love to have a great static analyzer for PHP. We need one, so please write one. If you're one of the folks who looks at my code and, oh, I could write that way better, do it. I don't want to be the guy who writes the static analyzer for PHP. You should have learned by now, after 20 years in PHP, you don't want me writing this stuff, right? I'm really good at coming up with the ideas and test implementations and sort of pushing people in the right direction, but the actual production code you run probably shouldn't be mine. I take too many shortcuts. Because, I mean, I wrote most of this in the weekend, and it's completely impossible to write a static analyzer in the weekend. It just can't be done. And when you look at my code, you'll see. Anyway, take this line of PHP. Echo substring ABC 1, 2, 3, or 1, 2 as an array argument. Obviously, this is not how you call substring. Right? It makes absolutely no sense to have an array argument as the second argument to substring. So, my static analyzer is called fan, not very creative, a PHP analyzer. And -a dumps the AST, and this is the AST that gets dumped. So there's a statement list that says echo, which is the echo here, obviously. What are we echoing? We're echoing a function call, so we have an AST call node. This @2 means just line 2 in my code, because I had the starting tag on line 1, so this is line 2. And what are we calling? Well, there's a name node that gives us the name of the function that we're called. And this flag that says name not FQ, FQ stands for fully qualified, which just means I don't have a backslash in front of it. So I don't have a fully qualified namespace for this particular call, and we don't have a fully qualified namespace. PHP falls back to the global namespace. So in this case, it's going to look for substring. Well, it's going to look for it in the current namespace. If it doesn't see it there, it's going to find it in the global namespace. If I had put backslash substring, this would say name FQ, not name not FQ. So I know I'm calling the substring function here. Then I get an argument list. So this is the list of args that I'm sending to substring. And The first one is a very simple argument. It's just string ABC, and that just shows up as the literal string ABC, because that's what I have here. My second argument is more complicated because it's an array. So it says it's an array, and it has elements, and then each element has values. So the first one has value 1, the second one has value 2. And that's it. That fully describes my little program here. And my static analyzer then goes through and looks at this, and it knows, it has a big include file that has all the built-in functions in PHP, and it knows that substring should take a string and an int. And it looks at that and going, type error on argument number 2, because I walked the tree and I got to here and I said, whoa, I was expecting an integer, and I got to here. I was expecting an integer and I got an AST array node. That's wrong, and my static analyzer can just spit out and say, that's not what I expected. And it's a little smarter than that. It actually does a little bit of generics, because it looks at these elements and sees both of them are integers. So it says, I saw an integer array, an array of integers. It arbitrarily just checks the first 5. So if your first 5 are integers and your 6th is a string, it'll still think it's an integer array. Because we don't have generic support in PHP, there's no better way. I mean, you can tweak that number in the analyzer if you really want. You can set it to 100, but it's going to be very, very slow for large arrays. But anyway, so this is my very, very pragmatic approach at building a static analyzer. And it catches tons of things, not just argument things. It just walks the tree and looks at stuff that it didn't expect. Try it. I like it. And Lorna had already gone through a lot of this stuff earlier. I'll skip quickly through this. Return types. This is the syntax, colon, the type that you're returning from the function. If you get it wrong, you can get an error, which you can catch if you like. We have cursive scalar typing and strict scalar types. So basically, you can now say on the scalar types, this is string, an int, and a float, and PHP will try to coerce it to those. And if you can do it, even if you send it the wrong types, like you send 1, then a string, and 3, as long as you can, PHP is able to coerce the types without any data loss, then it'll do it and it won't complain. If you do want it to complain, you can turn on in the caller, you can say, I want strict types. And then it will complain and give you a fatal error. Even though there's really nothing wrong with passing a string 1 to something that takes a 1, you can have PHP complain and be really pedantic with you. This will probably only work for new code. If you try to turn this on for existing code, your world is going to suck. It's just not going to work very well. For that, I prefer my static analyzer approach. You run the static analyzer against something and start cleaning up. And once the static analyzer runs clean, then you can start thinking about maybe turning on strict typing here and there. Anonymous classes, just like anonymous functions, means you don't have to declare the class. You can just create the class on the fly and use it. So null coalesce operator returns the first true element in the list, right? First PHP true-ish element or non-empty element. So A and B, right? A is null, B is 1. It's going to return 1. C or B, both C and B are set, so it's going to return the first one, which is C in this case. A, B, or C. A is null, B is 1, so B is going to return A, X, or C. And here's where the coolness, or where it really solves a problem. It does not complain if the variable is not defined. Right? So you don't have to do a bunch of is set, is not empty checks on this stuff. You can turn this stuff directly into the coalesce operator. Also means if you have a typo here, you're not going to see it. It's not going to warn you. It's just going to be false. So be aware that this is like an if empty or if not empty call in here. Spaceship operator. Lots of discussion about which actual spaceship it is. My son tells me it's the TIE Advanced X1. Because obviously this would be a TIE fighter if we had chosen that. TIE Interceptor, TIE Bomber has 2 circles in the middle. People are saying it's a TIE Bomber, it's not. It's a TIE Advanced X1. This is all from my son, so if you want to complain, you can complain to him. He's 13, so be nice. You use it in comparison functions, mostly. We've had lots of trouble with people not knowing how to write a stable comparison function for things like usort. If A is greater than B, then later on B has to be less than A. And some people's comparison functions were not stable like that. A was greater than B and B was greater than A at the same time, apparently, according to the comparison functions, because their logic was all messed up. And I mean, you can get it messed up because you basically had to write something like this before. Now, you can just toss in the spaceship operator and you will not make that mistake again. Exception on fatals. It's just what it sounds like. Most fatal errors now have been turned into exceptions. So if it does fatal on you, you can catch it and continue, or try to continue. You can't really continue, but you can at least catch it and maybe print out better error messages. It also means, because it's an exception, now you can do a nice stack trace of where the fatal happened by default. So that part is nice about it. And it's especially nice for chain stuff. I don't have a nice example of that, but if you have a whole bunch of chain method calls and something in the middle of your chain ends up returning null, which is what happens a lot, then you're trying to call a method on null and things blow up. And because you don't realize that something in the chain could potentially return null, then you have to split it all up and call them each individually and then put it together. Now you can just put a try catch around the whole thing and bail out that way. Closure call. Basically, you can force a call on a closure and pass it in the class that you want that call to apply to dynamically. It just turns this type of code into a much cleaner, this version of the code. Not a big deal. And we've removed a whole bunch of PHP 4 features, stuff that we have been hinting and signaling for over 10 years that we would get rid of. We have finally yanked it. So the old ext ereg functions is now completely gone. So if you still have ereg stuff, and that ereg library, Henry Spencer hasn't updated it since like 1946. So you really shouldn't be using it. And a lot of this stuff is driven by external changes to us, where libraries we have been relying on for generations simply aren't up to speed anymore. So yes, and I get a lot of people complaining about the fact that ereg is gone, but look, the library is gone. Tough. You have to modernize your code a little bit. And it's not that hard to convert ereg to preg. It really isn't. We also got rid of the eval modifier on preg. This one might hit a few more folks because it is a bit annoying to convert this over. It's not that hard, and I'll show you an example of using preg replace callback instead of using an eval. But there are just too many security issues with calling a direct eval, usually on data that comes directly from the user. And there are just too many ways that you could get it wrong. So it was a big, big gun that was aimed at your foot, right? And all you had to do was just touch the trigger and your foot was gone. So that's all gone. And a whole bunch of other things in there. You can read through the list yourself. Most of it is not a big deal. If you have a class name string in your code, you're going to have to change it, sorry. And a few others. Hopefully you don't have a class name string. Looking at you, Drupal 8. They have fixed that now in Drupal. And those other ones as well. We now own those words, sorry. 64-bit integer support on Windows is very nice for the Windows folks. Because even on a 64-bit Windows machine, you still didn't get 64-bit integers with PHP. It took quite a bit of work to get to that on Windows. And a whole bunch of integer edge cases, overflows, underflows, have been cleaned up now. Plus, we have also made it possible to have string lengths greater than 2 to the 31st, right? So greater than 2 terabyte strings. Not quite sure why you would need strings that big, but now you can do it. There's no real reason we should have the limit. We just never really, well, at least I never imagined that you'd be playing with data inside a PHP script that was that big. But people do. I mean, you can do file upload, and you can manipulate it with image functions and things like that directly in memory. And PHP is binary safe, so you can load an entire movie file into PHP and do stuff on it. And people do. If you can do it, people do it. All right, so parse error on invalid octals. This one caught, and at least in the Etsy code base, it caught probably 5 or 6 places in the code where we were doing that. Where silently before, something like 0855 would end up just being 0, right? And you wouldn't necessarily catch it unless you had really good unit testing. Now it's a fatal error, it's a parse error when it hits that, because 08 is not a valid octal number. Any number that starts with 0 is octal, and you only have 0 through 7 as valid octal numbers, right? It makes no sense to have something 08. It mostly happens in date type stuff, like make time and things like that, where you're putting in month and days literally, and you end up with a 0. Uniform variable syntax, this was to enable the AST. There was just no way to build a clean AST with some of the weird exceptions that we had to the parsing order in PHP before. And the big one that hits you is this first one, that when you have this, and then you have an array dereference, so you have an element on an array, and you're referencing that inside this. In PHP 5, this would dereference the contents of the belongs to array and find the column element, and then use that as the property, and it would access that property, right? Which is kind of weird. Why isn't it left to right? And in PHP 7, everything is now left to right. So in PHP 7, this will now look for the $belongs to property, and then find, so the property in the class called belongs to, and then it will take the element column off of that. You can still get the PHP 5 behavior, but you have to toss in some curlies to say, do this part first. And my static analysis for you, and tells you that you might want to look at this. This is not, if this is PHP 5 code, this is going to behave differently in PHP 7. Now, if you wanted it to work that way in PHP 7, that standing analyzer check is kind of bad, but there's a switch on it that says don't assume PHP 5 code, so you can turn it off. This hit me in my presentation system, actually, because I was going through and very quickly changing my preg replace /e, because I had a bunch of those. I have these weird markups. Stop that. I have these weird markups so I can toss in the title of my presentation or anything like that into a slide, because I reuse my presentations all the time, so I don't have to rewrite my presentation just because I went to a different town or something, right? I can just put : city, : and my current city will end up in my slide. So I'm cheating badly there. And the way I did that was to just do a /e and then put in this variable called pres, and then whatever I found in here, right? So if it was city, you would look for the city property in my pres class. But we don't have /e anymore, so I had to fix it. So this was my very quick hack. So do preg replace callback. My callback function goes and finds the first match, and then looks for that first match in the pres class. But I made the PHP 7 mistake, right? Because it's left to, I wanted matches 1 as one unit. I didn't want pres matches and then one off on the whole thing. And my static analyzer came up and told me that, hey, this expression may not be PHP 7 compatible. So my tool actually caught my mistake on there, and the easy fix is just to toss in curlies. Other feature, Unicode code point escape syntax /u, and then curlies, and you can put in the code point. So there's a right to left and a funny smiley. There's a new Intel char class as well. It's been added to the Intel extension. And we're looking to release in October 2015, hopefully. We released the first beta 2 days ago, Thursday, whenever that is. I'm in weird time zones. And hopefully, if the beta releases go well, we're still on track for an October release. There's some grumbling about some exception handling or things that might delay it, but we'll see. Sorry. Yes, release candidate 1. That's what I meant. If our release stages go well, we're still on track. We're done with the beta stage. We're in release candidate 1, and we'll see. So a little bit more on the performance. We had mostly Dimitri, Chen Chen, and Nikita working hard on this stuff for about 1.5 years, or Dimitri for even longer. And the way they did it was they took WordPress and they just hacked away at WordPress, not touching the WordPress code itself, but hacked away at PHP continuously. So if we just look at the time, this is 100 requests against the WordPress 3.6 front page. And it started off in January 2014 at 26.7 seconds to load this. It was on a slow machine. And then over the course of the year, you can see that they just kept improving the time that it took to load that 100 times. Just going through and figuring out what can we make faster, what can we yank without breaking WordPress, right? And then if we look at the instructions, same thing. So this is the machine instructions, and it started off at about 9.4 billion, trillion, I don't even remember the units here. Billion, 9.4 billion instructions to do those 100 WordPress pages. And we ended up at 2.9 billion instructions. So cut the number of instructions by a factor of 3. And if you think about it, I mean, we have this big complex program. You now say, hey, you only get 1/3 of the instructions to do exactly the same thing and don't break anything. It's not that easy. Imagine your own code saying, look, delete 2 out of 3 lines in your code. Throughout your entire code, you only allow 1/3 of the code to do exactly the same thing. For very new code, sure. But for code that has been around for 20 years, that people have been iterating on for 20 years, basically, telling them now you have to do the same thing in 1/3 of the code, that takes some serious hacking. And a lot of things changed internally. So the zval size was shrunk from 24 to 16. The hash table size reduced from 72 to 56. Each bucket shrank a lot, 72 to 32. So now something like this, where you're continuously appending to a string, another array to an array. In PHP 5, that takes 43 megs of memory. In PHP 7, that takes 6 megs of memory. And when you're moving less memory around, you can do things faster. Much more CPU cache friendly, new memory allocator, somewhat similar to JEmalloc, much faster hash table iteration API, array duplication, so when you're copying arrays back and forth, it's a lot faster now. There's a fast CPP, so certain functions internally, functions that are called a lot, now has a faster way of parsing parameters. And a whole bunch of other things too. We haven't done the JIT yet. There was a test JIT, but it didn't really help. So the way I like to think about it is we haven't played our JIT card yet. We still can. And when we do, look out. If we can write a decent one, of course. So, to finish with some benchmarks, don't trust them, do your own. I have all my test box specs, everything I could think of that you might want to know to replicate my benchmarks. It's in here, all my configurations, everything is there. Drupal 8, you can see the difference here. PHP 4, 5.4, 5.5, 5.6. We got better. Each iteration, we were quite proud of our performance improvements, right? Which looks a little silly now, because that's PHP 7 and this is HVM 3.7, right? This is for 20 requests per second. If we look at the latency at 20 requests per second, we can see that the latency dropped as well, right? Dropped in half. And it doesn't really matter if we go up to more. This is 40 requests per second. You see the same trends, same down at 5 requests per second, right? So I have it in here for completeness, but basically it matches across the range of scalability. WordPress 4.1, HHVM is still faster. Now, WordPress is an interesting case because both the PHP team and the HHVM team uses WordPress as sort of its benchmark, right? If we can make WordPress faster, awesome. Anything should be faster, which isn't quite true. The real reason we use WordPress is that the code is quite simple. So other projects are way more complicated. So when you're starting off, you start with WordPress because it's easy to get WordPress running. It's harder to get something like Drupal running because it uses way more features of PHP than WordPress does. WordPress is very thin on the number of features it uses. But anyway, so you can see it's way more than twice as fast on WordPress. But HHVM is even faster, which annoyed me a little bit. I was like, what the hell? All this work and we're still not as fast? So there's a solution to that. Now, the solution is a little bit of a hack, but GCC has this thing called feedback-directed optimization. It's basically like a little JIT in GCC itself. So what you can do is that we now have support in PHP 7's makefile to generate a profile. So you can build a new PHP 7 and type make profgen. So now it sets up PHP to read profiling data. Then run it against the code that you're going to use. So in this case, I run it, if you use php-cgi, you can give it the -t argument that says run this 1,000 times. And I'm running the front page of WordPress. Because the front page of WordPress loads in most of WordPress. It includes everything. So as long as it loads the front page faster, it'll run most of WordPress faster as well. So I do that 1,000 times. Then I go back and I say, hey, prof clean and prof use. That tells GCC, use the profiling data that I generated. So this is now a WordPress-specific build of PHP 7. It's probably going to run Drupal 8 much slower, but it's going to run WordPress really, really fast. And you might laugh, but if you're a WordPress shop and all you do is WordPress, why wouldn't you build a WordPress-optimized PHP? You should be building your own PHP anyway. You shouldn't rely on some Debian build guy somewhere or some Red Hat build guy to build a generic thing that works everywhere because you have a very specific system that runs very specific code. So I don't think it's as silly. And people always laugh at me when I talk about FDO, but I think it's cool. I think it's cool that you can, and at Etsy, I'm going to build a PHP 7 and I'm going to profile against the Etsy ORM because all of our code goes through the ORM. If I can make the ORM just 5% faster, awesome, right? And I build PHP at Etsy anyway, so why wouldn't I build an Etsy-specific or tuned version of PHP 7? Anyway, with that hack, it's now a statistical tie. It's still, I mean, 664 versus 666, but that's within the margin of error of my benchmarking here. So I went from 627 up to 664, and HHVM is at 666 on this one. So it worked. All right, a few others. PHP BB, again, PHP 7 is way, way faster than PHP 5.6. MediaWiki, this one has been optimized for HHVM, so here we're lagging behind a little bit. I didn't try FDO on MediaWiki. I think we're too far behind to catch up with FDO on this one. We'll see if we can do something on that later, but for now, if you're a MediaWiki shop, you probably should be using HHVM. It's faster. OpenCart, we kind of just throw our hands in the air and going, well, whatever. You can see, yeah, it's faster on PHP 7, but not by much. HHVM is struggling as well. And the reason we're struggling is that it spends 98% of its time in the database. And nothing we do in PHP is going to make your MySQL run faster. Sorry. And if all you're doing is just full table scans continuously on every single request, well, whatever, right? It's not us you need to talk about performance. You need to talk to your database, or maybe fix your queries. Wardrobe CMS, this was mostly to try a generic Laravel application. This was just the first one I found on GitHub that used Laravel. And you can see PHP 7 runs Laravel apps quite well. Just about twice as fast as PHP 5.6. Geeklog, another simple app I found. Again, faster. Magento, this one, Magento is tough. You can see the numbers. On others, we're talking about 500 or even 1,000 requests per second. This is the same machine, right? Magento, we're in double digits, not 4-digit numbers in here. But yeah, not quite as fast as HHVM yet on Magento, although there's been some tweaks lately. These numbers are 2.5 months old, so we've been improving a little bit, but so is HHVM. Do your own test. Track, ticket tracking app. Again, faster. This was the only one that broke, actually. So I've been going through all these large applications that I just installed and ran. This was the only one I had to fix to make it work on PHP 7. And the thing that broke was, again, that stupid order thing, where they had this, right? And I had to toss in curlies on it to make it work. So if you see this weird unexplained thing that's suddenly a variable or a property in a class that works fine in PHP 5 and is suddenly empty in PHP 7, track it down and look for big chains like this where you see a property and an array reference on a property inside a class. Chances are you just need to toss a few curlies in there and it will fix it for you. Cache, it's this downtime app that's quite nice actually. Again, twice as fast. Moodle, I couldn't get Moodle working on HHVM, but there are a whole ton of Moodle installations all over the world. My son's school uses it, for example. If you have kids, I bet your kid's school uses Moodle as well. And it is quite a slow application. I think a lot of school systems and system administrators are going to be happy with PHP 7 for their Moodle. ZenCard, another one that's quite slow because it spends a lot of time in the database. And you can see we didn't get any improvement from 5.3 to 5.6, even though we actually made a bunch of improvements, but it just didn't help ZenCard. But PHP 7 does get a bit more, and that's mostly from the memory savings. CPU-wise, it's still doing all the full table scans, but because we can now store things, arrays, so it's probably reading a whole ton of crap back from the database and storing it. And by the fact that we're storing less in memory means that we can go a little bit faster. So that's probably where the increase is. Help us test. It's easy, really easy. There are many different ways of doing it. I packaged up my dev environment just because I've been doing this for a long time and I have a nice workflow of doing it and switching PHP versions. So I figured, well, let's give everyone that same workflow. So I just packaged it up as a Vagrant box. You can install it, git clone this URL, right? CD into the directory, type Vagrant up. Takes a little while, especially from the conference Wi-Fi here. Has to download. It says 1.5. I think it's up to 1.7 gigs now, or 1.6 maybe. So do it on a fast connection, and then Vagrant SSH into it. And it's a standard Vagrant box. You can configure it, and you can mount shares and all the same stuff. It has a default IP of 7.7. You can change it, of course. But now you should be able to point your browser, and you'll have the PHP 7 info box should come up. You can switch versions inside. Just type new PHP and the version you want. So new PHP 5.6 will give you PHP 5.6 dev. If you want the debug version, you can type new PHP 5.6 debug. So it has 20 pre-compiled versions. So 5.3, debug, non-debug, thread safe, non-thread safe, from 5.3 all the way up to 7. That way, it's easier to test if it's something that broke in your application. You can quickly switch back to 5.6 and make sure that it's not also broken in 5.6 and has something to do with the environment as opposed to the language itself. I also like it for extension development. That's really fast to go into the Vagrant box and then compile your extension for every version of PHP very, very quickly just by typing new PHP and switching back and forth. You can build any version. To build the latest version of PHP, just type make PHP 7, and it's going to go and fetch it and build it. Same for 5.6 or any of the other versions. There's also a make PHP world that'll just do everything, rebuild every version. But 5.3 doesn't change, so there's no real reason to rebuilding those. You can do it manually. PHP source is the directory everything lives in. You can go in and play around in there. In fact, if you want to do your FDO build, which you should, you can use the box to build yourself an FDO. And that's where you get it. I think I have about 6 minutes for questions. Yes, Lana. Is 7 going to improve the traditional long tail of adoption for PHP? I certainly hope so. I think there is more reasons for people to upgrade now. I think there's more competition at the ISP and cloud provider level as well, where there are already cloud providers that have PHP 7 support, right? So, and it's not that hard to do. So I don't see any real blockers. In the past, ISPs have just dragged their feet because there wasn't any real demand. But the fact that your app will run twice as fast on the competition's cloud or the competition ISP, I think that's going to be a big draw for someone to spend an afternoon making PHP 7 one of the options that people can choose when they're choosing their PHP version. So I think availability of PHP 7 is going to be pretty good. Now, whether users are going to go after it, some will. Hopefully many will. We've gone to great lengths to make sure that we haven't broken too many things. And the things we've broken, we've been trying to sort of shout from the rooftops, hey, this is why we broke it, this is how it's broken, this is how you fix it. The upgrading guide is pretty good. You should read it. So I hope we can get folks onto PHP 5. Off of 5.5, 5.4, there's a lot of people still running 5.3. And remember, the delta from 5.3 to 7 is even bigger, right? And you may not think twice as fast. Is that interesting? Especially if you're just like 1 or 2 servers running a code. For big companies that can cut their number of servers in half, if they're going from 500 to 250 servers, they can just look at the money involved and say, yes, this is obvious, right? Of course, they're not going to actually pull out 250 servers. It just means they can use those servers, or they can load so many new things into their application that weren't viable before. But anyway, it's easy for a large company to justify this. But for the small folks on one server, if you try it, your app just feels more responsive. Every click just snaps up. Whereas in PHP 5, it gets there, right? In PHP 7, it just goes, and it just makes the whole thing feel more professional, feel nicer. So even the single server instances out there, I think once you try it, and once you see other people's apps, when he's like, why is his WordPress so fast? Mine kind of drags, right? Like, it's PHP 7. I should do that too.
I come from the IT side. And, we now we're looking to use 57 months supporting. But what we actually see is a lot of people complaining because we kind of get rid of old versions like 1 month after the support, and kind of now we edit it at the same thing. But people complain about my PHP, why do you support X, Y, Z of PHP, because why do you have to change something? And that's the thing that we hear. Like, for example, is one hosting in Germany, it is called PHP 4.
Yeah. But
it's a pretty game, but
I mean, we're for the video, just discussing human nature. Humans are just. It's human nature not to want to change things. Hey, my stuff is working. I never want to touch it again because that's effort. I don't want to make any effort, and I understand it. And then, I mean, then you do go to a provider like one-to-one. You say if they're still running PHP 4 and your code runs fine on PHP 4 and you're happy with that, well, maybe you should go to that provider. Of course, you're probably going to get hacked. You're probably going to. There's some cost in not wanting to upgrade, not wanting to actually maintain your code over the course of 12, 14, 15 years, or however many years ago PHP 4 was, right? So, yeah, I mean, and if you can live with that cost, okay, doesn't bother me too much. But I think on the security front, all these recent hacks are actually helping us a little bit because people are getting more paranoid and the non-techies are starting to ask questions going, whoa, could this happen to us? And the programmers will come back and say, yeah, because we're running on 10-plus-year-old code and you haven't given us the time, the money, the people to actually make this upgrade. So if you want to fix it, give us the resources, we'll fix it. So I think it'll help. We'll see. I don't know.
So I think recompiled binary you at the beginning. Two questions. First, if I change a PHP file, I do not have to delete the recompiled binary. It will automatically recognize it.
Yeah, so the question is about the file-based opcode cache. And yeah, it'll recognize the fact that it's changed. It keeps track of that for even the shared memory version, it keeps track of that, right? So if it's changed, then it'll go and it'll invalidate the disk version and it'll redo that one.
You are not going to run PHP in a combined language, so that we will get a WordPress.exe, which must be stored on the server.
So the question is, are we going to turn PHP into a compiled language? No, we're not going to do that. You could theoretically distribute the file-based version of, I mean, I showed you the whole var temp structure there. You could theoretically package that up and send to people. I don't really see why you would want to. We already have far, which is kind of does collect all this stuff in. And the very first time you hit it, it'll build the compiled version. So shipping the compiled version, yeah, you could do it if you wanted to, but it's not going to hide anything. It's not going to help you make sure people don't steal your code. And that's usually the direction that this question leads to, is how do I hide my code? It's like the answer is you don't. Good, okay. Yes. There was, yes. So what's our plan for porting current extensions to PHP 7? They are well underway, and most extensions, all the core extensions have been ported already. Now, and most of the PECL extensions have been ported. There are a few stragglers still. Now we're tracking down GitHub things that are way outside the scope of the PHP team, and we're poking those folks and asking them, hey, what can we do to help you get this up? And there's a tracking page. There's a Go PHP 7 ext. If you look for that, you'll find big document, big table of all the different extensions we know about and what their status is. There's an RSC channel on Freenode, Go PHP 7-next, right? ext, right? Go PHP 7-ext. And you can ask about that in there. Or talk to Lorna. She's championing that stuff. Yes?
About the ASP, the report of reading the ASP, the file in the core of PHP photo, because I can think
No.
of lots of fun ways to hide modification of the ASP.
Yeah. So currently, so the question is, can you by default get AST out of PHP? No, you have to add an extension. We're currently not distributing that extension with PHP, only because it's not really quite ready yet. Nikita wrote it, it's on GitHub, it's called PHP-AST. It's very small, it's easy to compile. We probably will include it in PHP 7.1. It just wasn't ready by the time we had the code freeze. He wasn't ready for it yet, but it will be in there because it should be part of PHP. Not enabled by default, but it should be easily available. And these days, it really is easily available, right? It's not hard to, people who are at the AST level can very, very easily build PHP AST. Yes? Yes. It's called fan, github.com/rleodov, PHAN. What can you do if PHP 7 segfaults when you run your stuff on PHP 7? Well, your first thing is get a backtrace. We have some instructions up on bugs.php.net on how to generate a backtrace. If you get a core file, it's easy. If you don't get a core file, if you can narrow down the piece of code that does it and do it from CLI, then it's easy because you just type gdb php and run. Okay, if you know how to do a backtrace, so that's the answer. You file a bug, include the backtrace, and if you can narrow it down to the snippet of PHP code, Chen will fix it within like 20 minutes of you filing that bug. Time zone dependent, he's in China. If he's sleeping, it'll take him a little longer, but a really specific bug report that says this piece of PHP code generates this backtrace on this seg fault, which generates this backtrace, he's all over those. He's so fast at fixing it. Now, if you send a report that says, well, I have this huge application, it's proprietary, I can't tell you what it does, I can't show you the code, but it's seg fault somewhere, and I have no backtrace, then it's going to take a little longer. Something else?
Can I just point you to the CI?
Yeah, file a bug and put the link in, sure. Okay. Are we out of questions? Really? Are we out of time? Okay. We're out of questions and time. Thank you very much.